Welcome to another episode of VirtualX MasterClass session with Mr. Kanyile. Today I want us to look at the coordinate geometry or the analytical geometry. This is one huge section in your paper 2 after Euclidean geometry and trigonometry. It's about 40 marks in your exam, so it's a sizable number of marks. So let's make sure that we claim these marks. This section, analytical geometry, is divided into two sections. There's a section that deals with figures, and there's another section that deals with circles. Today I want us to look at a section that deals with figures in particular. Like any other figure, we call it coordinate geometry or analytical geometry because it happens within the coordinate system, the Cartesian plane. If we've got a line, if I've got just this line, there's a lot of Euclid of coordinate geometry or analytical geometry that we can do out of this. Remember, figures are made out of straight lines. Y equals to mx plus c. If I've got a figure, whatever figure it might be a straight line, it might be a triangle, it might be anything. It is made out of straight lines. So it is vitally important that you should know more about straight lines. We should know that if I've got a line like this one, its gradient is positive. If I've got a line like this one, its gradient is negative. Those things assist me when working on analytical geometry. If I've got a line like this one, there is no gradient, there is no slope, the gradient there is 0. So understanding straight line graphs will assist me a lot. If I've got this line and I've got another line parallel to it, I've got to understand the notion of parallel lines. I must know that if lines are parallel, the first gradient is the same as the other gradient. This line will be the same as this line, the parallel lines. I'm just talking about lines that make figures. At times you might have a line like this one, another one crossing. If this part here gives me 90 degrees, this line and this line, if I multiply them, m1 times m2, I will get -1 at all times, perpendicular line. We call those perpendicular lines. So those are the things that are important when I'm dealing with analytical geometry. I go there with an open mind. Of course, I know that there are different formulae that are important in the first part of this section. Of course, the distance formula is important. The midpoint formula is important. The gradient, this also is important. The tangent equation of a line. We've got two lines that we can use there. Of course, the circle with the center at the origin, with the center which is not at the origin, where A and B are the coordinates of the new center. I want us to look at how they set this part in the examination. Firstly, I want us to look at this problem that was set in March 2009. It was question 1. We're given a figure. Understanding the types of figures becomes important. The 6 types of triangles, the 6 types of quadrilaterals will give you a better understanding, as well as their formulae becomes important, their volumes becomes important in this section. And at times you must think of trigonometry in this part. Suppose you are looking for the equation of this, the area of this triangle. That's where you can go and steal the area rule from the triangle formulae, which is your analytical geometry. But I see it's a particular figure. Yes, of course, this figure is made out of different straight lines. And let's see what is the first question here. So when we're giving analytical geometry, go expect to be asked about the distance between the 2 points. You can be asked about the gradient of a particular line. Being asked about the gradient, you can be asked about that particular equation. You can be required to find a particular theta. Maybe if you've got a particular theta here, you might be able to find this theta. Remember that what is important is that this angle lies on this line. So this line's gradient becomes important because tan theta is equal to m. That's where that formula of tan theta equals to m comes from. Right, let us look at what we have here. The first question says, find the gradient of BC. And I do know the formula for gradient, change in y over change in x. The first question says, find the gradient of BC. Where is BC first? This is BC. Now remember one thing. If I've got this line, we said the gradient is positive. If I've got this kind of a line, the gradient will be negative. Now let's look at BC. In this particular case, we're just looking for the gradient of BC. It is this form. So the gradient will be positive, the gradient of BC. I know that the solution that I must get here is positive. And I know which formula to use. The formula says, let's write, you can write it y2 minus y1 and so on and so forth. So m is equal to, this is how I remember it. I say y2, y at b minus y at c over x at b minus x at c. That's how I do it. So that I will just go and look at y at coordinate b. Now, this is b, this is c. You will never go wrong. What is y at b? Y at b, this is x, this is y. So y there is 0 minus. What is y at c? Y at c is 1 over. What is x at b? X at b is 3 minus. What is x at c? X at c is 6. What is the answer here? This is 0 minus 1. It is minus 1 over 3 minus 6. It is minus 3. Therefore, the gradient of BC is equals to negative, and negative is positive. It is 1 over 3. Did I expect to get a positive answer there? Yes, I expected a positive answer, and that's exactly what I got. So it is important that when you look for the gradient, you just check whether you're going to get a positive or a negative gradient. If I was looking for this gradient, it's going to be negative. This one positive, negative, and so on and so forth. So you look for what you expect. You must know exactly what is it that you're looking for. The next question, find the equation of AD. Where is AD? Okay, I think it is important that I should indicate that these two lines are parallel. This line is parallel to this line. Now, we talked about parallel lines this side. Whenever we've got lines that are parallel, we know that those two gradients there will be the same if there are two. Now, what is it that we're looking for here? We're looking for the gradient of BC. But we know that this line is parallel to this one. What is that telling me? This gradient is the same as that gradient. The slope is the same. That's what we mean by a gradient. It is the slope. So when we're looking for the equation of AD, if I'm looking for the equation, remember what is it that you're looking for when you're looking for the equation of a line? Y is equals to mx plus c. Or let's just take this. If you're looking for the equation of a line, you're just looking for m and for c. So we're just looking for two things, gradient and the y-intercept. Y-intercept is the point where the graph cuts the y-axis. So that's what we are looking for. Find the equation of AD in the form y is equal to something. So in actual fact, we're just looking for the gradient and c. Remember, there's one thing good about mathematics. It pulls you step by step towards a particular solution. We're looking for the gradient of this one, but we're told that this one is equal to that one. Now we're looking for the equation. So the equation is the gradient and the intercept and the y-intercept. That's what we're looking for. So I tell the person that is the examiner in this particular case that I know what you're trying to ask me. We are looking for the equation of AD. But I know that the gradient of AD is the same as the gradient of BC. The same as what? What was the gradient of BC? As 1 over 3. Why is this 1 over 3? So we already know the value here, it's 1 over 3. It's because line AD is parallel to line BC. And wherever we have parallel lines, those two are the same. So in the equation, y is equal to mx plus c, we already know the gradient. And we are short of the y-intercept. Now, there are two formulae when it comes to the straight line graph. I also have this other formula that says y minus y1 is equal to m into x minus x1. This and that is one and the same formula, depending what you are given. In fact, you can use any of the two. At the moment, we've got our m, our gradient, which is here. Let's write that one down. We have y minus y1 is equal to m into x minus x1. This is the formula for the straight line graph. But we want it in this form. I must not forget that. So I've got y. Okay. Let's see what we have in that graph, in that formula. What is it that we have there? He says, number one, we know the gradient. We know the gradient. We know that m is equals to 1 over 3. What else do we know? We also know point A. We know point A. What are the coordinates for point A? 1:6. It is advisable that whenever you have a gradient at any point, just go and use this formula. It makes life easier, especially when dealing with paper 2. Let's do that. Let's substitute. So we're going to have, this is x1 and y1. This is the gradient. So it's going to be y minus, what is y1 in this particular case? It is 6 is equals to, what is my gradient? It is 1 over 3 into x minus, what is x1? It is 1. I've made my substitution. Well, let's move on. Take the 6 that side. I'm going to have y is equals to, this times that, it's 1 over 3x. This times that, it's minus 1 over 3. This times that, it's plus 6. Therefore, y is equals to 1 over 3x minus, or it will be plus 17 over 3. This is how we'll go about finding the equation of a circle in this form. If you like, you would have used this formula as well. Where there is m, you push in 1 over 3. Where there is x, what will you put in x? You are going to put 1, and where there is y, you push in 6, and you'll have this unknown, which will get to be 7 over 3. Then you write the formula in the form y is equal to mx plus c. So that is how we go about finding the equation of a particular line. So when it comes to equation, you are spoiled with different, 2 different formulae that you can use. Number 3. This next question says, show that t is equals to 8. I want to show that this value here is 8. Now we've got plenty of options to use there. Let me look at it. Show that t is equals to 8. If I like, I may use the equation that I've already found. Because t in this particular case, what is t? It is on this line AD, which we know its equation. Let's try that one. Let's use line AD, and because we know the equation of that line. What is the equation of the line? It says y is equals to 1 over 3x plus 17 over 3. That's one way of doing the same thing. Show that t, remember these are ordered pairs, x and y. This is x, this is y. You substitute in there. What is t? This is x, this is y. So t, x, y. So instead of y, I push in t. Is equals to 1 over 3. What is my x there? My x is 7 in this particular case. Plus 17 over 3. Right? You work this thing out. 1 over that in 7 over 3, and that is over 3. 17, 18, 19, 20, 21, 22, 23, 24. Okay, let's work it out and see what we have. We've got t equals to, this is 1 times 7, it is 7 over 3, plus 17 over 3. Both of them are over 3. These are all over 3. What is 17 plus 7? It's 24. 3 into 24 goes 8 times. Yes, t is equals to 8. This is one way of finding this t. Or if you like, you can, another learner will see it the other way. There is a gradient here and there is a line. We've just used a line for now where t is. But I can also use a gradient there. Yes, I can also use the gradient of AD. Do I know this gradient? Yes, I know that gradient to be 1 over 3. One person might just use the gradient. Let me just try the gradient this side. Gradient of AD. MAD will be equals to AD. Okay, why? It's t minus 6 over x squared 2 will be 7 minus 1 over 7 minus 1. This is the gradient of AD. but I know the gradient of AD. I know the gradient of AD. What is the gradient of AD? It is 1 over 3. It is 1 over 3 is equals to t minus 6 over 7 minus 1 is 6. This is what we have. Let's cross multiply and see what we'll get. Take 6 this side. It will be 6 over 3, which is 2. 6 over 3, which is 2, is equals to t minus 6. If I take 6 this side, it will be positive. I'll be left with t equals to 6 plus 2, it is 8. No matter which method you use, you'll find that your t will be 8. You use what we have. I had a gradient and I had an equation where d can be found. So whatever method that you use will come to the very same answer. Now I want us to move on to the next question here. It's 1.4. Calculate the lengths of AD. Where is AD? That is AD, BC, BC, and AD, and AB, AB. Okay, we're just looking for these 3 distances. As I said, it's all about formula in this section. If you're looking for the distance, we use the distance formula. The length, the first one that we need to find is AD. Of course, I must have 2 coordinates. If I'm looking for the distance AD, remember we already have T. We already have T to be 8. We found it there, that T is equals to 8, all right? So we've got coordinates of AD. Okay, so distance AD is equals to x at A minus x at D all squared plus y at A minus y at D all squared. All this is in a square. That's how you find the distance formula. All that is squared as well. All right, then you just substitute. So distance AD will be equals to, what is x at A? X at A is 1 minus 7, x at D, which is 7, this is squared, plus then 6 minus 8 in this particular case. This is also squared. All this is in a squared form. This then will give us, what is 1 minus 7? It is minus 6. Minus 6 squared, 6 times 6 is 36, plus 6 minus 8, it's minus 2. Minus 2 squared is 4. So this then will give us square root of 36 plus that, which is square root of 40 units. That is how we'll go about finding the distance of AD in this particular case. We found AD. We're looking for BC now. Let's find BC quickly. Distance of BC will be equals to the square root of x at B minus x at C, this is squared, plus y at B minus y at C. This is also squared. That's all distance formula is all about. That's why it's usually 2 marks. That's where we should be getting maximum marks. Non-negotiables. What is x at B? We're looking for BC. What is x at B? Let me look at B. X at B is 3. It's going to be 3 minus 6 all squared plus y at B is 0 minus 1. 0 minus 1 all squared. This then will be, what is 3 minus 6? 3 minus 6 minus 3 squared, it's 9, plus 0 minus 1, it's minus 1 squared, and 1, it's 1. So this will be square root of 10. Right, that's that distance. The last distance that I want us to find is the distance AB. Distance AB. It is x at A minus x at B all squared plus y at A minus y at B. Others use y1 minus y2 minus y1, and so on and so forth. It doesn't matter. What is x at A? You are looking for distance AB, the longer one now, distance AB. So at x at A, it is 1 minus x at B minus 3 all squared plus y at A, 6 minus 0. 6 minus 0 all squared. All this is under square root sign, don't forget that. So distance AB, in this particular case, 1 minus 3, it will give us minus 2 squared, it is 4, plus 6 minus 0, it's 6. 6 squared, 6 times 6, it's 36. So this then will give us square root of 40. The AD and AB, AD and AD are the same. These two distances are the same. All right. That's how you go about finding lengths. If you don't want to use y2 minus x2 minus x1, you can use the actual alphabets. It will take you directly there. All right. The next question they want us to find, to show that AB is perpendicular to BC, where the two lines intersect, they form 90 degrees. This is AB and this is BC. We want to show that this angle here is 90 degrees. How do we show that? Remember earlier on we talked about perpendicular lines. If this line is like that, this other one is like this will only be 90 degrees. If this is 1, this is 2. If gradient of the first one times the gradient of the second one is equal to minus 1, then this would be 90 degrees. So all that you need to show here is to show that this gradient, when we multiply them, we get minus 1. But we know one gradient. We know this gradient of BC, that it is 1 over 3. So the other one must be negative, and that negative must be 3 for us to get perpendicular lines. So since we know this gradient of BC, that is 1 over 3, so for these two lines to be perpendicular, this gradient definitely must be equals to negative 3. Now I want us to work on this gradient and see what we have first. Let me find this gradient. Let's find this gradient of AB. Gradient of AB. Because we do have the gradient of BC. What is the gradient of AB? Let's work it out. 6 minus 0 over 1 minus 3. 1 minus 3. What do I get? 6 minus 0 is 6 over minus 3. It's minus 2. 1 minus that, it's minus 2. Therefore, the answer will be minus 2 for 6 minus 3. This is the gradient of AB. Now, if we can show that the gradient of AB times the gradient of BC equals to minus 1, then the two lines would have been perpendicular. Now, the gradient of AB, MAB, times the gradient of BC. This is what we are working out. If this gives us minus 1, then we'll be okay. Gradient of AB, we've just calculated as minus 3, times the gradient of BC. In this case, it is 1 over 3. When I multiply this, I get minus 1. Therefore, AB is perpendicular to BC, because the product of their gradient gives us minus 1. So it is true that those two lines are perpendicular, because the product of their gradient gives us minus 1. The next question that was asked in this year, let me see, calculate the area of this quadrilateral ABCD. Calculate the area of triangle ABCD. ABCD. We're looking for the area of that whole figure. People will do so many things to find this area. Others will cut this trapezium into different ways. Others will cut it in here and form a triangle here and a rectangle here and add the two areas together. You can do whatever you can, but the easiest way is to use the formula. We do have the formula for the area of this of a trapezium. The area, we'll say area is equals to half the sum of parallel lines times perpendicular height. This is the formula to calculate the area of a trapezium. So it makes life easier when you know your formula from your measurements, grade 11. So the area of this figure is equals to, there are things when it comes to formula that you can readily have, like if you calculate when we talk of the area, we talk of the area of the base. When we talk of the volume, it's the volume of, it's the area of the base times height. All formula we'll deal with that when we go to measurements. This then will be let's do it. It is half, what is the sum of parallel sides? These two are sides that are parallel. Let's look at them. These two sides are parallel. It's half the sum of parallel sides. So it's 2 root 10 plus root 10. What is perpendicular height? This is perpendicular height because we've proved that these two lines are perpendicular. So it's times 2 root 10 again. All right, this is what we have. If I add these two, what do I have? This then will be half of root 10, 2 root 10 plus 1, it will give us 3 root 10 times 2 times root 10. That's what we have. So 2 here goes once, so it's 1. This is what we have. Eventually we'll have, what is root 10 times root 10? It is 10. 10 times 3, it is 30 square units. So that's how you go about calculating the area of a trapezium. Right, the next question in 1.7, it wanted us to find theta, this angle of inclination of BC. Theta. Of course, we are given, you must check, this theta lies on this line. Do we know the gradient of this line of BC? Yes, we know the gradient of BC is 1/3. Therefore, there's a formula that says tan theta is equals to m. That's the formula we use. Tan theta is equals to a gradient. What is it that we're looking for in this case? In this case, we're looking for theta, just the angle. So we know that tan theta is equal to, do we know the gradient here? The gradient of BC? Yes, it is 1/3. Therefore, theta in this particular case will be equals to arctan of 1/3. Therefore, theta will be equals to whatever value the calculator that will be giving us there. Thank you.